Today we start 2-5, which is solving equations that will have absolute values. So I believe you might know these as naked numbers if you had math with Mr. Gleason. And basically, like the way he taught it was when you drop the bars, you drop the curtains, you drop the negative. So an absolute value measures the distance from a number to 0. And since distance isn't negative, until you get into like doing some physics problems, we don't say that I went negative 80 miles to go somewhere. We said we went 80 miles west. So that's why when we drop the bars, we drop those negatives. So the first thing up we're going to try is evaluating. And basically it's going to be just like before where I'm given an expression. That's going to be this entire piece right here. And from there, I'm going to take what m equals and plug it in. So absolute value bar 4 plus 6 minus 14. Now what you might notice is I'm going to somehow make those absolute value bars very big and bold. I might make them really tall. I might maybe even highlight them. Somehow make it obvious that I've got absolute value bars, because otherwise it's really easy for this to look like 14 plus 61. That'll really mess up your answer, so be careful. All right, treat the absolute value bars like parentheses. So that means simplify everything inside first. So I'm going to do the 4 plus 6, which is 10. Okay, and when the absolute value bars are completely simplified on the inside, what you're going to do is drop the bars, drop the negative, and if it's already negative, it just gets, if it's already positive, it just gets to stay positive. So this becomes 10 minus 14. And 10 minus 14 is negative 4. And yes, my final answer is allowed to be negative. It's just that when I drop those bars, that's when I would drop the negative. Let's try another one here. I always get questions on this one. Well, how come, when I drop the bars, drop the negative, don't I need to turn that into a positive sign? And the answer is no, you do not. Because you simplify everything on the inside before you drop the negative. So I'm just simplifying here. I did 4 times 2 is 8. Now I'm going to do 3 minus 8 is negative 5. And when I drop the bars, drop the negative, that is going to be a positive 5. Now you'll notice this happy little minus sign got to stay. And now I just have 23 minus 5, which is 18. Part 2 is going to be solving. With this, I need to understand that when I drop the bars, drop the negative, it's possible that I would have had either a positive number over here or a negative number there. So for that reason, we're going to have 2 different answers. So you're going to split this into 2 equations. Drop the bars. You do not have to drop any negatives this time when you're solving. Just write down what's on the inside and let it equal that positive 4. But then also remember that it could have been a negative 4 before I dropped the bars, dropped the negative. So on the second equation, I turned the answer, the negative 4, into a negative. Now solve. I would subtract 2 from both of these. There's your answer. Now if I were you, I'd go ahead and kind of double check those real quick. Take 2 and plug it back in. 2 plus 2 is 4, and the absolute value of 4 is 4, so that one works out. Now try the negative 6. Negative 6 plus 2 is negative 4. Drop the bars, drop the negative, positive 4 does equal 4, so that's good. So I start off on this one, and I have 3n minus 4 equals negative 1. And on the second one, I'm supposed to make it negative. Hold on a second, it was already negative. Uh-oh. Stop a moment. When you see that it equals a negative number, stop and ask yourself some questions here. If I have, let me erase all this here. If I have an absolute value, when I drop the bars, drop the negative, this is always going to be a positive number. okay, and it's going to equal a negative 1. When is a positive number going to equal a negative number? Never. The answer is no solution. All right, and I think that's all. We'll probably do some examples in class tomorrow.